Hello everyone. Today's topic is comparison test, and this is our 7th lecture of module 2, that is lecture number 2.7. So let's start comparison test. Okay, let me tell you frankly that there are two types of comparison test, but I will discuss only one type of comparison test. I will discuss that test which is very useful for your semester examination. Okay, clear? So start comparison test. Actually the name is comparison test, so obviously there will be at least two series, yes or no, because we have to compare. One series will be given, and to check the convergent or divergent property we need another series. Okay, so let's start. Suppose we have, let summation un be a positive term series, positive term series. Okay, and there exists another positive term series summation vn. Okay, now if limit n tends to infinity un by vn, this is equals to L. Okay, what is un? This un means nth term of the series un. Okay, you have to understand the difference. If I am writing summation un, this implies the series un, and if I am writing only un, that means this is the nth term of the series un. Clear? Okay, you have to understand the differences. So limit n tends to infinity un by vn, this is equals to L. And what is L? L is some non-zero finite number. Okay, L is some non-zero finite number. Now if this result hold, that means you are in question paper the series un will be given, and you have to take another series vn whose result is known. Okay, now you have to calculate un by vn, this ratio un by vn, that means nth term of un divided by nth term of vn. Okay, then calculate the limit, and the limit is some non-zero finite number. Okay, if this hold, then summation un and summation vn both converge or diverge together. Okay, that means if this L, if you are getting the limit a non-zero finite number, then if vn is convergent, un will be convergent. If vn is divergent, un will be divergent. And what is summation vn? Summation vn will not be given in the question paper. You have to take a series vn, okay, depending on the series un. I will discuss how to take the series vn. Very simple. Okay, and whose result is known. The convergent divergent result of vn will be known to you. Okay, now if the limit is some non-zero finite number, then you can say that if vn is convergent, then un will be convergent. If vn is divergent, then un will be divergent. Clear? That's why I have written that language, that both converge or diverge together. Okay, so let's solve using a problem. Question: test the convergence of the series 6 by 1 into 3 into 5 plus 8 by 3 into 5 into 7 plus 10 by 5 into 7 into 9 plus dot dot dot. Okay, first step, you have to find out the nth term un. This is the first step for every series problem. You have to find out the un. So solution, here un equals to, here un equals to, just think in reasoning concept. Okay, so first let's calculate the denominator. Okay, in first term denominator is containing 3 numbers, second term 3 numbers, third term 3 numbers. So obviously in nth term there will be n numbers. There will be 3 numbers. Okay, so what will be the numbers? Let's take a look. Okay, this is 1, 3, 5. Okay, all the numbers are odd number na, 1, 3, 5. Okay, or you can think in this way, the first digit is 1, first digit of every number, first digit 1, this is 3, this is 5, all these are odd numbers. So obviously odd number means that will be either 2n minus 1 or 2n plus 1. Okay, now if n equals to 1, if n equals to 1, if I take the 2n minus, first take 2n plus 1. If I take 2n plus 1, so when n equals to 1, for the first number you will get 2 plus 1, that means 3. But here the first number is 1. So obviously we cannot take 2n plus 1. So we have to take 2n minus 1. Now let's verify. When n equals to 1, you will get 2 minus 1, that means 1. Yes, obviously first number is 1. Now if n equals to 2, so you are getting 4 minus 1, that means 3. Yes, this is 3. When n equals to 3, 6 minus 1, that is 5. So this is 5. Obviously it is satisfying. So the first one is 2n minus 1. Clear? Now next number. This is 3, 5, 7. All the numbers are odd number. Okay, all the numbers are odd number. So odd number means 2n minus 1. This is not possible. Okay, so this will be 2n plus 1, 2n plus 1, or this may be 2n plus 3, etc. Okay, if I take 2n plus 1, so when n equals to 1, the first number is 3. Yes, it is satisfying. When n equals to 2, so 6 plus 1, 4 plus 1, that means 5. Yes, it is satisfying. When n equals to 3, 6 plus 1, that means 7. Yes, it is satisfying. So second number is 2n plus 1. Okay, and the last one. Actually the gap of every numbers are 2 na, 1, 3, 3, 5, 3, 5, 5, 7, 5, 7, 7, 9. So obviously next number will be plus 2. Listen, no, 1, 3, 3, 5. So increasing by 2 na. Similarly 3, 5, 5, 7, increasing by 2, 5, 7, 7, 9, increasing by 2. So obviously 2n minus 1 plus 2. So this is 2n plus 1. 2n plus 1 plus 2. So what will be the next number? 2n plus 3. Okay, this is our denominator. Now numerator. When it is 5, numerator is 6. When 7, numerator 8. When 9, numerator 10. That means increased by 1 from the last number. So this will be 2n plus 3 plus 1. That means 2n plus 4. Okay, 2n plus 4. Now question is how to understand then when we have to apply comparison test. This is the main question. How you can understand that you have to apply comparison test. Let me tell you, if un is in ratio form, ratio form means numerator divided by denominator. Okay, and there is a degree difference. There is a degree difference between numerator and denominator. Okay, there is a degree difference between numerator and denominator. Okay, now tell me, what is the degree of numerator? 1 power na, n power 1, so obviously degree of numerator is 1. And what is the degree of denominator? 3 factors. This is 1 degree, this is 1 degree, this is 1 degree, so the product will be 3 degree. So obviously there is a degree difference, yes or no? So we can apply comparison test. Now you have to choose, so we can apply comparison test. So obviously we have to choose another series whose result is known. So we have to choose Vn. Okay, so let summation Vn equals to, now how to choose the series Vn. Now here Un is given, and you know what is Un, you know the degree difference. Now what is the difference of degrees? Degree difference is 2 na, degree difference is 2, and if the degree is less in numerator, okay, if the degree of numerator is less than the degree of denominator, then you have to take 1 by some power of n square. Let me explain again. Suppose the degree of numerator is less than the degree of denominator, okay, and less than by any number, let's say m. Okay, degree of numerator is less than degree of denominator by the number m, and here in this problem m equals to 2. Okay, so if degree of numerator is less, then you have to take the series Vn as n to the power m. Okay, 1 by n to the power m. Clear? And if degree of denominator is less than the numerator, then in case you have to choose n to the power m. Okay, in that case you have to choose n to the power m. So in this problem, here we have here the degree of numerator is less than degree of denominator, and the difference is 2. So obviously we have to take the degree on denominator. So this will be n square, summation n square. Clear? So now calculate. So obviously what is Vn? Nth term Vn equals to 1 by n square. Now calculate limit n tends to infinity un by Vn. So un by Vn, so this will be 2n plus 4 divided by 2n minus 1, 2n plus 1 and 2n plus 3. Okay, and divided by 1 by n square, so n square will be on the numerator into n square. So this is equals to, if I take common n from each factor, so limit n tends to infinity, taking common n from each factor, so this will be n cube into 2 plus 4 by n divided by 2 minus 1 by n into 2 plus 1 by n into 2 plus 3 by n. Okay, and there will be n cube. So obviously n cube cancelled. Now limit n tends to infinity. Okay, if limit n tends to infinity, so limit n tends to infinity 1 by n, that will be 0. So this will be, this is equals to when limit n tends to infinity, this will be 2 plus 0 divided by 2 minus 0 into 2 plus 0 into 2 plus 0. Clear? That means we are getting 2 by 8, and this is equals to 1 by 4. And the condition was, this is the L na, and the condition was L must be non-zero finite number. Obviously this is non-zero finite number, so we can say that U and Vn both converge or diverge together. Now what is Vn? Convergent or divergent? This is of the form summation 1 by n to the power p. So obviously we can use p test. So by p test summation 1 by n square is convergent, because here p is 2. 2 means greater than 1. So this is convergent. So by comparison test, so by comparison test summation un is also convergent. Clear? Okay, let's solve another problem. Question. Test the convergence of the series of the series 1 plus 2 divided by 2 cube plus 1 plus 2 plus 3 divided by 3 cube plus 1 plus 2 plus 3 plus 4 divided by 4 cube plus dot dot dot. This is the question. Solution. Okay, so first calculate un. Here un equals to, okay, first take a look on the numerator. This is the first term, this is second term, this is third term, and so on. Okay, so when n equals to 1, that means first term, the numerator is 1 plus 2. When n equals to 2, the numerator is 1 plus 2 plus 3. When n equals to 3, numerator is 1 plus 2 plus 3 plus 4. So when nth number, that means n equals to n, so what will be the numerator? N equals to 1, it is ending at 2. N equals to 2, ending at 3. N equals to 3, ending at 4. So when n equals to n, that will be end at n plus 1. So this will be 1 plus 2 plus 3 plus 4 plus dot 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 plus n plus 1. Clear? Divided by. When n equals to 1, the denominator is 2 cube. N equals to 2, 3 cube. N equals to 3, 4 cube. So n equals to n plus 1 whole cube. Just reasoning. You have to, there is no any short trick. Okay, you have to think, you have to, this is hit and trial method. Put n equals to 1, put n equals to 2, put n equals to 3, and so on. This is your un. Okay, can you simplify this un? We know the formula that sum of first n natural number, sum of first n natural number, that means 1 plus 2 plus 3 up to n. The formula is n into n plus 1 divided by 2. But here we have up to n plus 1. Yes or no? So 1 plus 2 plus 3 plus up to plus n plus 1, extra 1 term. So what will be the formula? Just you have to put n equals to n plus 1. So this will be n plus 1 into n plus 2 divided by 2. This will be the formula, because here we have n plus 1 terms. Okay, sum of first n natural number is formula n into n plus 1 by 2. And sum of n plus 1 natural number is just put n equals to n plus 1. This is the formula. So what you are getting, n plus 1 into n plus 2 divided by 2 into n plus 1 whole cube. So obviously n plus 1 cancelled. So you are getting n plus 2 divided by 2 into n plus 1 whole square. This is your un. Now tell me, which test you can apply? Obviously comparison test, because this is in the form ratio form and there is a degree difference. The degree of numerator is 1, degree of denominator is 2, because n power is, highest power is 2. So degree of numerator 1, degree of denominator 2. Okay, degree difference is 1, and which one is smaller degree? Obviously numerator. So we have to take n power in denominator. So let summation vn equals to, degree difference is 1 and difference is on the numerator, so we have to take on denominator. So this will be summation 1 by n. Clear? Now apply comparison test. So limit n tends to infinity un by vn. So this is equals to limit n tends to infinity. Acha. Un, that means n plus 2 divided by 2 into n plus 1 whole square divided by vn, divided by 1 by n. N will be on the numerator. So into n. Okay, so I am taking common n from each factor. So this is equals to limit n tends to infinity n square into 1 plus 2 by n divided by 2 into n square. So this will be 1 plus 1 by n whole square. N square cancelled. So now put n tends to infinity. When n tends to infinity, so this will be 1 by, actually 1 plus 0 divided by 2 into 1 plus 0 whole square. That means you are getting half. Okay, and half is obviously non-zero finite number. Let me write symbol. This is not equals to 0. So non-zero finite number. So according to comparison test, u and vn both converge or diverge together. And we know what is vn. Summation 1 by n. Na? So by p-test, summation 1 by n is divergent. Okay, so by comparison test, summation un is divergent. Okay, so in this way you can solve this type of problem using comparison test. Remember, when you can apply comparison test, first one is if un is in ratio form, second one is if there is a degree difference between numerator and denominator, you can apply comparison test. Second point, how to choose vn if there is the difference on numerator, that means the degree of numerator is less than degree of denominator, then you have to choose the n power on denominator for the series vn. Okay, similarly, if degree of denominator is less than degree of numerator, then you have to choose vn, the n power of vn on numerator. Clear? Okay, very simple. But one more point, some exceptional case. Here I have written the statement that L is non-zero finite number. So obviously you will ask me that what will happen if n equals to 0, or what will happen if n is infinite, because here we have two conditions. Na? L must be non-zero and finite. So exceptional case, so limit n tends to infinity un by vn, this is equals to L. So if L is non-zero finite, then we know that result. Okay, now if L is equals to 0, what will happen if L is equals to 0? So if L is equals to 0, then summation un is convergent if summation vn is convergent. Clear? If L is equals to 0, summation un is convergent if summation vn is convergent. So if summation vn is divergent, then we don't know. Then we have to apply another test. Okay, this is only one way statement. If L equals to 0, then summation un will be convergent if summation vn is convergent. There will be there will not be any other conclusion, just only one conclusion. Un will be convergent if vn is convergent. If vn is divergent, we don't know when L equals to 0. Okay, now second point, if L equals to infinity, then summation un is divergent if summation vn is divergent. Okay, so when L is infinity and if summation Vn is divergent, then summation Un will be divergent. So if summation Vn is convergent, then we don't know. Okay, so just remember these 2 points. If first point is L is equals to 0, okay, summation Vn convergent, this imply that summation Un is convergent. Okay, if L is equals to 0, summation Vn is divergent, no conclusion, we cannot say anything, no conclusion. Okay, number 3, if L is equals to infinity and summation Vn divergent, then summation Un divergent. Okay, but L is infinity but summation Vn convergent, no conclusion. Clear? There will be no conclusion. Okay, I think this topic is very simple, and let me tell you frankly, this type of you will not be given this type of exceptional cases. Okay, so now series is very easy concept, but it is totally depending on practice. Okay, you have to practice all the previous year question papers, all the question bank problems. Okay, then and also all the textbook problems. Clear? I think comparison test is very clear for you. Thank you so much.